Students, we have started the purely capacitive circuit which is there in the chapter of alternating current. Okay, so students, before moving on to the derivation for the purely capacitive circuit, let us draw the purely capacitive circuit. The basic diagram that we draw for each and every circuits, let us draw for this purely capacitive circuit. Okay. Okay. So this is the direction of the current. You can see the voltage, alternating voltage that is being applied, and here is your capacitor. Okay. Okay. So students, this figure is for your purely capacitive circuit. Now you have seen the voltage, that is the alternating voltage that is being applied, and it makes the current to flow from this direction. Okay. So let us write the equation for the alternating voltage that is applied for this circuit. That is, I'm writing the equation of the voltage here, V equals to V naught, the usual equation that we write, sine omega t. Okay. Now student, at any moment, if Q be the charge stored in the capacitor C, Q is what? The charge stored in the capacitor C, then what will be the value of this terminal voltage? That means voltage across this will be Q by C. Okay, the Q by C will be the terminal potential difference. Okay, I am writing here terminal potential difference. I am writing in short, that is PD. Alright, now this potential difference, that is your Q by C, opposes the applied instantaneous voltage in the circuit. Understood? This terminal voltage, this terminal potential difference rather, opposes the instantaneous voltage in the circuit. That means it restricts the instantaneous voltage in the circuit, this terminal potential difference. Alright, so you can ask me then, what is the net effective voltage that is being applied or that is there in the circuit? So the effective voltage of the circuit, effective voltage in the circuit is, what will be it? It is denoted by VE, that is for effective voltage, V naught sine omega t, that means this part minus your Q by C, because this is also your terminal voltage. So effective voltage will be your V minus your terminal potential difference, that is V naught sine omega t minus Q by C, that means this part. Understood? It's very easy. So students, as there is no resistance in the circuit, have you seen any resistance in the circuit? No, there is no resistance in this particular circuit. So in this particular circuit there is no resistance. So according to Ohm's law, just recall the Ohm's law that you have studied in your junior classes. So we can write VE equals to IR equals to 0, isn't it? Why we are writing this Ohm's law? This is basically Ohm's law. I'm writing here Ohm's law. Why we are writing this, students? That this particular equation, that is VE equals to IR equals to 0, or rather you can say that VE equals to 0. Why we are saying this? Because there is no resistance in this particular circuit. From the diagram only you can able to write this particular equation. Clear? Okay. So let us write this equation mathematically. Just put the value of VE, that is 0, in this particular equation, and let us see what this equation will become. Okay. that is your equation will become, that means now I'm putting this 0, that is VE equals to 0 in this previous equation. Okay, so it will become Q equals to CV naught sine omega t. Understood? Okay, repeating once again, I am putting the value of V equals to 0 in this equation and I am getting this particular equation after putting the value of VE as 0. Okay, very easy. So we have seen the value of Q. Okay, what is the Q? Q is the charge stored in the capacitor C. The charge that is stored, obviously some charge will be stored in this capacitor. The value of this capacitor is your C V naught sine omega t. Alright, so what would be the value of alternating current? I am writing here, your alternating current I will be dq by dt. Okay, if you differentiate this charge with respect to time, you will get the value of I, that is dq by dt. Understood the differentiation? Hope you have studied in the maths classes. So what will be the value? See, the q value we have already got from this particular equation. This is the equation for the value of q. This particular equation for the q. This particular equation. So if you differentiate this particular equation with respect to t, I will get the value for the I, isn't it? So what it will be? dq by dt means omega c v naught. All these are the constants. Okay, this is the maths part. Cos omega t. Okay, I'm just doing the differentiation. C v naught and omega will come outside because these are the constants part, and sin omega t's differentiation one time will be cos omega t. Okay, very easy. So how we can write this particular thing in the form of sine omega c v naught sine omega t plus 90 degree, I can write it, isn't it? This is also your maths part. Okay, the associated angles. Okay, that is omega c v naught sine within bracket omega t plus 90 degree, because sine omega t plus 90 degree, students, will give you cos omega t. So I can write this particular equation, isn't it? Okay, so students, for this, that is this omega c v naught, how we can write it? We can write it as, that means this particular thing, only this constants part, I can write it as I naught sine within bracket omega t plus 90 degree. I can write in this way.